So, welcome to this talk. It's fun to have such a full audience. I hope you will have fun with this talk. I thought since this is in a cinema, let's get a bit into mood and let me tell you a story. See it as, let's start with a trailer for the talk, shall we? In the beginning, there was void, and every customer was seeing the same version of the website. Sad times. But then came along a product manager and spoke. What is this? I need to be able to test variants of our products. I will introduce something. And she took an off-the-shelf solution, and now every customer could see a different version of the website. And after it was done, she was happy and life was good. But then came along a data scientist and spoke. What is this? I need to be able to add complex algorithms to steer business processes. I will take this and make it better. And he wrote a complex decision system that he would call Smart Gateway because it could steer processes throughout the company. And after it was done, both were happy and life was good. And then came along a software engineer, audience here, and spoke. What the crap? What is this? If there would just come one wind, everything would fall over and crash. I will take this and make it better. And he would take the Smart Gateway and refactor it a bit to make it production ready. After it was done, all three were happy and life was good. But then all three looked at the thing that they have created together and spoke, what is this? How did this become something so much more powerful and beautiful than what we set out to do in the first place? Actually, we have built. This is now the part where I have to say this is a trailer, right? I couldn't tell you the whole story. You have to wait roughly another 35 minutes more to see what we actually built. And after the trailer, first comes the ad. So, hi, I'm Jesper. I'm from Outfittery. And I don't really want to do long job advertisement, and I hate these sponsor talks, but I need to explain a bit what actually is the problem that we ought to solve in what we've built. So this talk is about how we built this thing called Smart Gateway and what we do with that. But I need to give you a 2 or 3 minute detour of what we're actually doing so I can explain the problem. So what we're doing is we are in curated shopping, so we serve only men, so men can call us, come to our website, and say, please send me an outfit, which then, after a phone call or just with information on the website, some stylists, so real humans, go, pack a box, we send it to the customer, and the customer picks it up, is usually excited about the awesome quality of our products. Sorry, that's the sponsor part. And then this nice customer usually then watches some football games, works a few days, makes a vacation, and then maybe sends it back after 2 to 3 weeks. Meaning, it takes us 3 weeks to know what we actually sold, which is a problem when you think about steering processes and A/B testing. Also, everything that we do, this is a single product company dealing with physical goods. So everything is interconnected. It's very hard to do an independent decision in one part. So this is our order economics and business economics, not the real numbers, sorry. But let's drill a bit deeper. So some of the goods the customer get, right? What he didn't like, he just sent back free of cost. And that is good, we sold something, right? So this is what we sold. But this part here, the buying part, this is, we needed to pay for what we sold them, so it's not all profit. But there are also some other costs like logistics cost for packing this in the warehouse, the service costs, these stylists, for example, customer support, and other costs. And what remains then is operational profit. The problem here is now in the terms of A/B testing and process optimization is when you change one thing, you usually change everything of the else as well. Let's say, for example, you come up with a brilliant idea. It's curated shopping. Let's just send double the stuff to the customer, right? Probably they will keep one thing more, so this goes a bit higher, and then what we sold is a bit higher, but probably logistics cost will explode. So when you have an A/B test, you cannot just go for a single number. You need to go to a whole range of numbers, and you need 3 weeks to know what you actually sold and how high your logistics cost really was. The other way around, let's say the logistics guys, they would say, let's not send boxes, but send everything in paper bags. Yeah, probably customer happiness would go down, and definitely service costs would explode when customer support gets all these angry calls from people whose fashion got wet because of rain or whatever. So we always have multiple KPIs in A/B testing and multiple things to optimize on when we go for steering processes. And another thing that is true for our company, that this is basically the old model. So you had a customer, and then we have a stylist who packs them. They have an interaction, and there's a feedback loop going on between. What we are putting in is machine learning in the loop. So we build more and more tools to augment the expertise of the stylist to say, like, don't pack this item, pack something else instead, for example, because the customer returned something 2 years ago that was very similar to the item you just want to send to the customer. Don't do that. I have a concrete example how we do that later in the talk. So, and both things together is, so these process optimization problems and this augmentation of stylists is what we follow up as a data-driven vision. This is a transformation that our company is currently in. It starts from how do we collect data and how do we store it in a way that every process and basically everyone a customer in the company can access the data they need. How do we enrich the data? And in the end, how do we apply that data? So in this talk is about the infrastructure, the smart gateway that we need to apply that data. So all the data we gathered, how do we apply that knowledge to actually change something for our business? And how we do that from an architectural side, this is what to talk about. So, 3 chapters I have for you. The first one is, remember still this product manager and off-the-shelf product? That off-the-shelf product was Optimizely. It's a nice product. Looks like this. Your fancy charts, you add some JavaScript to your website, and then everything's fine. You can compare conversion. It's a nice tool. So that worked. And where it didn't work, then we used something like canary testing. We do blue-green deployment, so this is our high-level view of the stack. So you have some Nginx, then you have our Angular.js application, and then behind that you have a bunch of microservices that you call via REST. More or less the standard, I would say. And if you want to compare 2 versions, let's say of your website, nothing is easier just to deploy 2 versions of that thing and tell Nginx, please direct 50% of the traffic to that version of the website and 50% to that version. Then you just need to mark these sites by some cookie, whatever. So in tracking, you can find out like which version the user was seeing. And then you have a proper A/B testing framework. And that worked. So it's also pretty similar to how we do blue-green deployment. So when we deploy this one, it has a fault that we can fall back. So it's basically just an add-on on something that we already did. So and with that, life was good. We had A/B tests. Pretty much. Off-the-shelf product, 5 minutes integration time, maybe 5 weeks, and then it's canary testing, it worked. But there are some limitations to that. Talk would be pretty boring if I would end here. So this is really nice. If you have 2 versions into test time, it's really nice. But let's say you have 2 tests running. Then you have to build 4 versions of the software with the permutations of that. And Nginx needs to handle routing of 4 different versions of the website. And if you have 3 tests running, then it goes to 8, 16, 32. And of course, every of these versions need to be fail-safe, so it's more than 2. So in the end, then I have 64 versions of the code running, and everyone gets 3 users. It's nonsense. It doesn't work. Especially that an A/B test made one for something like 4 weeks. So it's absolutely not working. It's a nice thing, but we had 1 test. So this was not the thing to go for us. External tool, really nice, but most of them also optimizely are managed to build for tracking conversion. So you have a green button or a red button, like how many users go back past the green or the red button. But actually, this is not our problem. Our problem is that we want to display a green or red button, and after 3 weeks, then we want to know like which button made more revenue, and that's over 3 weeks of time. And that is a simple A/B test that we have. Or if you go for this, then you probably have to combine like 5 or 6 KPIs and see like what is the impact of that A/B test that you're running. So this was not it. But we also not only want to do A/B tests, we also wanted to steer our processes. And this is a very similar problem when you think a bit from a technology perspective. So let's say, take as an example, this guy who wants to order something. And throughout the signing up process, we need to decide, do we trust this guy? Do we believe that he will pay? So do we let him on by paying by invoice? So we send him stuff for, let's say, 1,000 euros, and we just trust him that he sends back or pays what he keeps? Yeah, maybe, but maybe not. So we have some decision-making process in the beginning, and you might say like, please, could you give us your credit card? We want to see like if you have at least some money. Or if we don't trust you at all, then maybe we expect you to pay 150 euros upfront, or 250 euros even. So, and this is a logic that is based on, for example, on external services that we call, or the address. Like, are you living at an address where someone already cheated on us? Don't expect that you can pay by invoice. Or if you have a CO address, and we don't know where you really live, so because you get the delivery to a company, you probably end up here. Probably for most e-commerce companies work that way. So this part we also want to do with the same framework, because from the code perspective, it's more like if call something, go this way or that way. It's an if-else switch in the end. It's a gateway. So this is why we invented something that, or the data scientists actually invented something that we call Smart Gateway. So the goals they had in this system were pretty simple. It should be integrated within the IT platform, so not some external tool, but our service should call some other service and get an answer. And this answer would basically be the answer on the decision point, go left or right. But if you would call the same point twice, please get the same result back. Could be something in the website, you call for a customer, red or green button, and then later on in some stylus tooling, you want to see if they had the red or green button, so you should call the same Microsoft, the REST REST API again, to get the same answer. So some simple caching of that. But we also wanted to add actually not just left or right, but we want to enter to complex decision-making logic, so we wanted to configure algorithms to map to these decision points. And of course, all of that should evolve and change over time. I mean, never anything stands still. So this is how it looks like. Pretty simple. So we have all these services, an order service, user service, customer service, the website, whatever. And they would just call the smart gateway, which is another microservice via REST API. Pretty simple. I'm at this point, this is my custom ID, should I go left or right? Something like that. And the smart gateway then do some voodoo magic within a black box that I'm going to explain a bit more. That would get the answer from. The interesting thing is this line of responsibility here. On this side here is the IT department. On this side here is the data department. So this is reporting to a CTO, that's me, and this is reporting to a chief data officer. So we work in this duality. It's not data, it's not part of IT, it's a separate entity with equal rights. So of course, this smart gateway also has persistence, so there's some database, but that's pretty much straightforward. So what makes these smart gateways smart? That's where it starts getting interesting. So you have data scientists, and we have 3 or 4 in the room who we can ask like how they actually do that. So essentially, they dig through the data, they find causality, correlation, like customers who have this profile would be more susceptible to that thing or whatever. So out of that, they create an algorithm, and we call that algorithm a decider. That's just our internal terminology. This algorithm can also have read access to data pre-aggregated data in a data warehouse. And we would pack this algorithm in a Docker container inside a small web server. So we can use a REST API to call that algorithm that we just deployed in a Docker container to get an answer from that. So inside this black box, we just have these deciders. And the configuration in the Smart Gateway is responsible for which decider to call, in which case we get an answer from. Docker containers, HTTP codes. Pretty straightforward, but very powerful when you think of it as a concept. It means we can change this decider over here or change the routing, and the callers are not affected. This is this encapsulation, what we have as different responsibilities. So we can move at different speeds. And some of these deciders also have data warehouse access. So the configuration, very simple. We have a two-phase approach there, which also comes from the data side. So first phase is we do sampling. So we decide like this call that we just received on the Smart Gateway, this traffic, to which experiment should we route this? We do this to run these experiments separately. I'll explain this more in a second. So we have first this concept of, okay, this decision point should be routed to this experiment. So these experiments can opt into traffic. And these experiments then define groups, and these groups map to a decider. That means each experiment can run independently from the other experiments and can have a different bunch of deciders. Let me give you an example of how that looked like. Let's assume this is the Smart Gateway, and we get a call in. Something like, what is the risk class of this user? Like the example I gave in the funnel. And we just have the information in custom ID. So what then first happens to decide is sampling. So we decide which experiment should answer that question. So we would route, for example, 25% of calls, 25% of the custom IDs that we get in should be answered by experiment A. And of the remaining ones, we take only the German traffic, and of the German traffic, only 50% is answered by experiment B, for example. So you can do also some criteria on this. And then you have two experiments running in separate, and when you change the parameters one experiment, the others is not affected, which is very important from the analytics side. So experiment A, for example, could be a very simple A/B test. So out of these 25% of users that we sent there, 50% get A, the green button, and 50% get B, the red button. Something simple as that. And usually this is also how we start when we have an optimization problem, for example, of steering processes. We first do this to two versions to see like, okay, how does, for example, customers, how do they behave in that sense? And after we let this running for some time, then we start a second experiment where we then have a bit more complex logic. So for example, we would see that the chance of users responding well to A or B is depending on the age. So this decider, this algorithm could be extremely simple. So we'd have something like, okay, if this customer is very young, then go for A else B. But we are not sure about the age range, so we have two algorithms that we deploy. Means we can compare the performance of these two by impact on KPI, revenue, for example. Or we can have something completely outrageous, neural network, AI, that have some extra complex algorithm. The point is you can deploy different variants of the algorithm, and in live traffic you can measure which one performs best without interfering to any other experiment that you have running. And this is something that we are doing since 2 years now. Works very well. And of course you need some default route, because this doesn't, it's a bit hard to foresee like what is 100%. So everyone else who doesn't match this cascade of experiments just gets some default answer. This is in a nutshell how our smart gateways work, how we do run A/B tests, and also how we steer processes and how we optimize the steering of processes over time, using this very simple framework, this one point in our platform. And with that, life is pretty good. We're really happy. One question now, yeah. How am I time? Let's see, shoot.
Okay. Is it a synchronous request from the front end up until the decider, or is it like asynchronous or cached or whatever?
In this point, the REST call, the smart gateway, is synchronous. But this is chapter 2, and then along came the software developer and complained about a few things among these. So life was good for about a year, and then we had some problem with this Python crap of code from the developer side, so the left side. So we said like, there's a few problems with it. The concept is really nice. It's a great MVP of a service, but now we need to make it right. So what were the problems? The first thing is this access to data here is not real time because the data comes via some ETL job every 8 hours or so. So you have a service here that has a local database that replicates some data to some data warehouse. And that means, for example, in this website sign up example, probably the data is not there yet. So that limits your problems and you have consistency problems there. The second thing is, it's really great. Actually, our data scientists, I'm really proud of them, are the first one in the company to use Docker, but they put it all on one machine, which is okay. And we learned a lot in operation and how to build that stuff and got operational experience. But this is a problem. Not only that this could fail, actually, I think in a year it failed only once, and then only for a short time, so it was not that big problem. But it means every of these microservices need to have the default implementation on their own. Meaning this concept of encapsulation was not true. So in the code, you had to know like what the default decider here was, and if it changes, then you have to default here. So it's kind of like, it didn't really separate concerns. So off we were, chapter 3. There along came a software developer and said like, make it better. And this is how we did. This is what we did. So we had a few very specific goals, more like from operation perspective in mind. So first of all, very important, the separation of concerns. So the process, the continuous, always ongoing optimization problem on business is not something that you want to have in your software. It changes the whole time. It's 2 different speeds of working. So the separation of concern for us was very important. We wanted to have the data access in real time, also solving some consistency problem, widening the range of things that we could do. And the whole setup, please, should be fail-safe, so production ready. So in order to do that, we also changed the organization. So this is just a very simple version of the teams that we have. Here you see IT teams, roughly structured by the customer journey. And then you have a data team which ran this service. What we did is we created a new team in the middle, which we call data delivery. And thereby also pushing the responsibility. So from the IT type, we took over this service, this smart gateway, by creating a new team to just handle that and a few related services. So we shifted this responsibility over and took this to us. This team is co-located with the data team, so they sit all in one room for shorter communication base, but still they have a different way of working. I mean, the R&D from data science work different than regular software development. So a few changes. Before, this configuration was one YAML file, and it got quite long over time, and when you have a change, then you potentially change. No. So we changed this to make this database-based now, because the old YAML file simply became too big. And the configuration is pretty straightforward. So for each decision point, so the thing that you ask for, left or right, we would define n experiments with their sample rate, like which traffic should go to that experiment. And then for each of these experiments, then defined n deciders, like 50% within the experiment goes to that. So we kept this encapsulation of experiment there because that is a very good idea to run long-running experiments in a long time. The only thing is then we now have a REST API to change this thing on the fly, making it easier to deploy a new version of configuration without breaking everything. Validation and all that stuff included. Another thing that we did in order to solve this real-time data access, we no longer wanted these deciders to access the data warehouse, because essentially all the data in the data warehouse is potentially stale, maybe stale up to a day. So we added another phase between this sampling and this experiments, which we called enrichment. So when a call comes in, the smart gateway is responsible for gathering all the data that is necessary and not the algorithm itself. Meaning this decider algorithm is now a pure function. That's basically a function that is side effect free. I mean, I have to admit they still do logging, but in terms of like in and output, it doesn't read from anywhere else. So we do enriching this data. This enrichment is configurable, and we can also use this enriched data to do part of the sampling and routing. For example, is this a call in Germany? So it's pretty much the same as before. We just added the first thing that we do when we get this call in with custom ID. We look up in the configuration and see like, okay, what data else do we need? Which other services should I call with this custom ID as parameter to get further information? So for example, I could call the customer service to get the address of a customer, something like that. I have other options, like for example, some local database that I can access, even executing some JavaScript. With that information, then it continues as before. I do the sampling and the experiment, and in the end, I end up in one decider giving me the answer. So we had still then the thing, okay, how do we make this production ready and fail-safe? So we overworked the Docker setup a bit more, proper build pipeline and things like this. We started orchestrating this Docker container via Kubernetes. So essentially, we now have a cluster of these things running. It's a very small cluster, just 3 nodes, where we can also, depending on load, spawn more instances of a type, depending on what decisions point we run. We did a few other changes. Instead of a local cache for the persistence, we now use a Redis cluster, which is nice. Then we added SQL again because we added the option for the enrichment that we have some pre-aggregated data that we can edit here. So data can, things like article-to-article relations, like which articles are similar, for example, which is a very complex operation which you just have to update every now and then. So we can use this data in the enrichment phase. And of course, the smart gateway would now call other microservices to gather information. This is a really nice setup. It's running since May, I think. Running fine. I have to say we're a bit proud of it, but at least we're happy with that. It works really nice. So for life is really good. So we do all of our A/B tests via this one thing. That means all our A/B tests are also audited in one place, documented in one place, and you know what is running on one place, which is another advantage. But we also use it for these decision points. There are many examples. One is kind of like the user discrimination, for example, like what risk class the user has. Another would be, for example, like what is the maximum amount of goods that we send out to that customer? So how much stock can go in a box in terms of value, things like this. And many more, which I can maybe talk more about it when it's not on video and in a smaller round. But there's also one other very nice thing that we're currently working on. When you think about that you want to optimize these deciders, which is basically an algorithm, and the data science teams is continuously improving these algorithms, it's very hard to put them in the live system. So not always you want to run an A/B test and then screw 20% of your users. But if you have a lower amount, then testing takes too long. You're aware of this is basically this concept of significance for A/B tests. So what we are now adding is that you can, when a decision point is called, you can also specify another decider which is just called, but the result is not used. So it's kind of like a shadow mode. So we can start a bit like blue-green deployment of algorithms. So you can start using a new algorithm in the back, which is called, but the result is not used, but of course recorded. So basically, our data scientists can look at the results of the decider over time, over a period of time, how that algorithm would behave live before they actually put it live, which is a very nice way of also improving these algorithms over time. And it's nice when you have one framework. So how much time do I have? 5 minutes. Life is good. Life is really good. So we are really happy with the setup because it allows us, for us, this is a really important cornerstone to make better use of the data that we have and apply logics that we can base on these data back to the business in any case. But actually, once we built this, we realized that actually we built something else. Do you already know what this is? Maybe it's just a small thing, but for me, this is even more exciting. So this is our setup. And these deciders here are pure functions to return like go left or right. But actually, these are pure functions. They can be everything. Anything is possible. You do not need to call this just to tell me go left or go right or which group I am on based on a complex algorithm. They can return anything. So what we actually build is a runtime environment for pure functions, by accidents. And our data science team start playing around with that. So someone else built something similar. I would not say that they copied us. I think that might be overreaching a bit. No, honestly. What we build is in nowhere near what AWS Lambda is about. But from the concept of our data scientists, it is serverless computing. They no longer worry about the resources where they run things. They no longer care about scalability. They just deploy an algorithm and let it play out and measure it over time, which is extremely freeing and powerful as a deployment paradigm. But we also use it then not only do decision points, the string of processes, we also do other things. Let me give you two very quick examples. One is, it's another thing that I cannot show. This is my masterful wireframes of the internal tool that the stylist use to pack a box. So this is just, imagine this is a wonderful website and of course an amazing GUI. And you have the customer information of the customer that just want to pack a box. And the customer information basically, via some relatively smart processes, applies filters on the available stock that we have right now in our warehouse. And so it's a filtering process and a selection process there. And the stylist then picks that available stock. So it's a bit like Zalando internal, so to speak, in order to pack the box that is then sent to the customer. This is the main tool that we use for that. And we made that a bit more smart by using the smart gateway that I just talked about. So whenever we stylists start packing a box, we actually send that customer ID and that order ID to the smart gateway. The smart gateway then goes to all articles that we have in stock, compared to the preferences and all the information that we have on customers. So for example, past order behavior, and calculate a score. A score of how likely it is that if we send this article to the customer, that it will keep it. And we use this score to encourage or discourage our stylist to pack that in the box. The stylist still has the final word because no algorithm is perfect. What we do is just we display kind of like a traffic light where red means like, please don't put it in the box, and we say like, the size might be wrong or return to similar items some time ago. And the cool thing is if the stylist overrules it, they need to write in why they do this so we learn over time, which is another important feedback loop that we have in there. So here we are not giving back a decision, we're actually calculating the score over a few thousand or few 10,000 articles using the same smart gateway framework. Another example is where we have return skins. So when customers return the box to us, they can say, this article, I would like something similar. So basically they can check boxes here. So these ones here. And for God, whatever reason, there was no automatic process about that. So actually some humans looked at this and then entered something in the system. And we wanted to change that because it's kind of like stupid to do that not automatic. But it's a bit complex because some returns look like this, where everything is crossed, but of course nothing should be reordered. So the problem is not that simple. And it turns out that with our logistics provider in the data warehouse, that would have taken us something like 3 months. So having this smart gateway and the ability to just play around with this a bit, having this carefreeness of deployment, so data scientists got on there and after a week hacked together a prototype that worked, put another 3 weeks in it, and now we have an algorithm that does that for us. So actually here, the input to the smart gateway is a TIFF scan. It's big. And the information now is kind of like an array, like which items in that order we want to create in the follow-on order, so get a replacement item to the customer. Just another example of what you could do with such a framework. So Also, these use cases led us to extend our framework a bit, coming to your point. So for this use case here, we need to send a lot of data in there, all the customer information, all the article information, historic data about how articles moved out and whatever. So it's something like 3 megabytes in and out. It's a lot, but we can handle that. And this one we can still handle synchronously because something like 4 or 5 seconds. This damn scan takes something like 2 minutes. So that is no longer synchronous. So the last thing that we did is actually added some using RabbitMQ in here. So have an making this call asynchronous internally, and then using a callback mechanism here. So you call and then give a callback URL, and then the callback URL is called when we have an answer. So asynchronous handling for these use cases. But even these cases work, and we're doing a lot more. Some of that we are still trying out, some of that I can't talk about, sorry. But all in all, I would say life is not only good, it's pretty awesome. So, but let me wrap up the way how I started. This is a cinema after all, so let's finish in style. But then all three looked at the thing and that they have created together and spoke. What is this? How did this become something so much more powerful and beautiful and exhilarating and awesome than what we set out to do in the first place? Actually, we have truly built a system that can run just any pure function. A/B tests and process steering are just the beginning. Maybe speech recognition is next. Or maybe with that, they started to brainstorm all the cool things they could do in the future. Time and the next hackathon will tell what they made out of it, and maybe I can come back next year to tell you more about it. Thank you. Thank you indeed. Are there any questions? One here. Do you want for the mic or just shoot ahead and I repeat?
How many people in your IT teams are working?
How many people we have in our IT team? 25. So right now we have 25 people in the IT team. The Smart Gateway, that was a team of 2 to implement this in the end, and we have 10 data scientists. That is the current setup. Over there. How the enrichment part knows what data is needed in the function. It's, I think, one of the more uglier part of the thing because it's a pretty complex configuration. So essentially, the input parameters are configured, which is more like a schema validation, like what are the in parameters, and they can be reused in the template mechanism, for example, and URLs to call these REST calls, and then again, what to take from these REST calls, or I think the whole answer from that REST call is then sent. So for example, you get a custom ID in, configuration is called this endpoint with this custom ID, and the response you put to the whole thing to the decider. That is, for example, how you would do REST calls. Another thing is you can execute a JavaScript, for example, or if you have pre-aggregated data, then it would be the same mechanism. Take the parameter in, put it in a template as an SQL query, execute the SQL query on a local data storage, and pass the result back to the decider. This is how we do it right now. It's pretty big and a bit unwieldy, but it works. Anything else? Then thank you very much. It was nice being here.